This is Lorraine Jamison coming at you for a second time today because she forgot to do one of the problems. Okay, so the last problem on quiz 14 was dx dt equals 3x minus y, and then dy dt equals 9x minus 3y. Sorry. So once again, you set it up as x prime is equal to ax, so 3, -1, 9, -3. And you take the determinant of that matrix while subtracting lambda from the diagonal. So you get -9 plus lambda squared plus 9. And then at the end you get negative lambda squared is equal to 0. So lambda is equal to 0 with a multiplicity of 2. So you subtract the 0 from the diagonals and set it equal to 0. So you get k1 is equal to 0.333 k2. So k is equal to 1, 3. And that's the first eigenvector you can find here. And as it's a multiplicity of 2, we still have to find a second eigenvector. So in order to do this, we have the equation x2 is equal to ke to the lambda t plus pe to the lambda t. And so to find p, what you can use is a minus lambda I times p is equal to k. So you just set up these matrices so that a times p is equal to k. And then you can plug that into your reduced row echelon calculator to get that p1 minus 0.333 repeating p2 is equal to 0.333. So you can set p2 equal to 0, p1 is equal to 0.333 repeating, so p is equal to 1/3 0. And all you have to do after that is you just substitute back into this equation. So x2 is equal to 1/3, that's the k, e to the lambda t, but since lambda is equal to 0, this just cancels to be 1. So 1/3t plus 1/3/0, once again, e canceling to 1 because it's raised to the 0th power. And then in order to find the general solution, you just add the two solutions together. So x is equal to c1, 1/3 plus c2, 1/3t plus 1/3, 0, and then close parentheses here. Thank you.